And here we go. Alright, what's up everybody? This is Ryan and you are watching episode 63 of my live stream Q&A. So yeah, let's jump into it. So what I'll be doing is just going to start with a recap of my content over the previous week. Just so everyone's up to speed on that, and in case there's anything which might be useful. And I see I did miss one of my articles in my list here, but yes, so just to bring everyone up to speed for Wise-Ass content over the previous week. We had a good number of videos. So first there was, to begin with, a video I created called How to Ask Questions About Software Development. So that video is actually in the description box almost towards the top, because I wanted to basically make a video to kind of explain how one should go about trying to ask questions of developers and asking questions in general. And the reason why is I get quite a broad range of experience levels and specificity of the questions that I'm asked, and so I wanted to do maybe a little bit of something to address that concern. And also, once again, to encourage beginners to please ask questions. So if you're a beginner, all you need to do is just state you're a beginner, and then I'm totally fine if you ask like a general question in that case. It's just when I get slightly more specific questions, but I'm not actually sure what your experience level is, it can be very hard for me to kind of predict what kind of answer would be most useful to you. So anyways, just wanted to cover that. We have, again, one of my reflections videos. So that video was titled How to Focus 16 Hours a Day, with the subtitle being Your Personal Standards Define Your Work Output. So obviously I don't work that hard every day, but the purpose of that video was basically, so over the past couple of months I had to once again completely redefine my capacity to study and code every day. So I basically just wanted to lay out the different things that I had to do in order to do that, with the understanding being that that's not a very sustainable way to live. It's something you might want to consider thinking about if you have a big challenge in front of you. Then you will need to, if you want to succeed, walk a narrow road of behaviors. But yeah, I just kind of wanted to share that because it was quite relevant to me. We have a couple WTF videos, so if you're not familiar, the WTF series, I've got a couple going on, stands for What's That For? Did you think it stood for something different? So there's Programming WTF, where I just basically talk about fairly language agnostic concepts in computing. There's Kotlin WTF, you can probably figure out what that one is, and there's also Android WTF. So basically in those videos I focus in on one particular topic and try to give some useful information. So we had Programming WTF, how to coordinate entities and repositories using a domain layer. So I actually want to change the name of that at some point, because I'm not even sure most people would be able to understand what I'm actually showing based on the names, but it's actually a pretty important video to watch, because there's going to come a point probably when you're building applications complicated enough that you either have to fill your presenter or view model or controller with a whole bunch of logic about the back-end data sources, or you need to start filling your back-end with logic, and you need to create to basically start to break separation of concerns in the model or data layer, more or less. So an alternative to doing both of those things is to implement a middle domain layer. So that's what that video is all about. And yeah. And then we have Programming WTF. Why test software? What should you test? Simple language and examples. If you're wondering about testing, please watch that video, because I can pretty much guarantee you that testing has been explained to you very poorly, and it's not actually that complicated. It's not easy, but it's not complicated. I won't go into the finer details, but and secondly, it's really important. It really is important to test your code, and I basically explain why with simple analogies. So do consider that video if you're curious about testing. I explain why you want to test and the basics of it in a non-technical example. So we have Kotlin WTF, so technical reasons / examples to prefer Kotlin over Java. So that was basically just cut from one of the live stream episodes, but I basically talked about some technical examples of why I prefer Java over Kotlin, because I've been getting all kinds of comments and questions about Java versus Kotlin versus React versus Dart or Flutter and all that stuff, and I'm trying to just avoid giving just unsupported opinions about things, because these topics are very, very opinionated, including my own. So I think it's just, on my end, it's just important for me to say to anyone wondering about which to use, don't just read one article and then just assume that that person's opinion was 100% correct. Don't listen to my opinions and then just assume, okay, well, obviously Kotlin is better than Flutter. Really, you know, the Flutter camp is gonna say pick Flutter. The Kotlin camp is gonna say pick Kotlin. The Java camp is going to very, very slowly die. I'm just kidding. I'm trolling. I still love Java. But what I'm trying to say here is no one really has a clear answer. I can give you some answers why I prefer A over B, but don't hold strong opinions on this topic, because you'll almost definitely be wrong. There's no easy answer. Anyways, I'm rambling. And then the final video was Kotlin, Android, model view, whatever architecture example with coroutines, sealed class, should be sealed classes, and result. So if you're curious about my architecture approach, a general overview of it, I would suggest checking out that video, because I basically go through pretty much the whole thing. And a final, more technical note, I am aware of the fact that my insanely loud CPU fan is affecting the audio quality. So in spite of moving it many feet away and kind of blocking it off, it's still quite loud. So I'm going to try and figure out a solution for that. But if you've been annoyed by that lately, you're not the only one. So yeah. And the only other thing is I wrote an article talking about how to, basically my experience in progressing through different levels of software architecture, and also just kind of, it was a response article to some opinions and perspectives I've been hearing lately. There does appear to be kind of two camps at this point. So there is a camp which I'm in, which are people who really strongly emphasize software architecture, and I have my reasons for doing so. And then there's a camp which basically says just do user stories and everything else will sort itself out. I think, so I'm not knocking user stories at all. I like user stories. To me, the answer really is somewhere in between, but in working a little bit in an agile approach and stuff like that, I am still very strongly convinced that just doing user stories with no upfront architecture design or forethought sounds like a horrible idea. But the article is basically in response to some opinions I've been hearing that architecture is useless, and it's just 100% about process and no planning is required. And my opinion, my general opinion is I absolutely agree. Don't do waterfall software development. Don't try and design the entire thing up front, because that just won't work. That's why we don't do waterfall software development methodology anymore. But I really feel like some people are kind of misunderstanding Agile as basically being something devoid of, basically approaching Agile as just follow a process that was cooked up by your project manager or whatever. Just follow the process and everything else kind of handles itself. And the problem with that approach is that, in my opinion, architecture is probably one of the most important things to consider. And so as long as architecture is still part of that Agile process, I'm happy. But I do like the ideas with Agile of, for example, prioritizing usable code, getting working code out as soon as possible, and the actual tenets that I learned of in Agile. Agile has turned into a word which appears to refer just to a very specific Scrum process, whereas to me Agile is more a set of principles with which you can apply to the software development process. So there's, again, it's a very opinionated topic, but yeah, that was the gist of that article there. Anyways, and again, I'm not knocking people who follow Scrum and all that stuff. That really is the most efficient way to build applications. What I'm pointing to is just kind of the death of architecture, essentially, that certain people are trying to promote. So anyways, carrying on. If you enjoy the show and would like to see me do it better, please do consider following WiseAss on your preferred social media networks. We've got Facebook, Twitter, Instagram, Medium, and we have a Slack channel down below if you would like to get some help and feedback from the WiseAss community. I, of course, have one rule: don't be an asshole or I will ban you. But I've never had to do that before, so I'm quite happy to say that. Also, this show is brought to you in part by my wonderful Patreon supporters. So we have my friends A, Cameron, Graham, Hank, Pijak, Shoku, Sushil, and Trevor. So to all those people, thank you very kindly. If you would like to support WiseAss in a more direct fashion, please do consider supporting me on PayPal or Patreon. And last but not least, I would just like to thank everyone in the WiseAss Slack group for just being awesome people. It's just really, it was a really wonderful experience, just kind of knowing that even though over the past couple of months, for reasons I can't really go into, I wasn't able to contribute much at all to the WiseAss community. And so to just know that it's something which carries on to a large degree in my absence is very wonderful, because that was quite an experience over the past couple of weeks and months. Anyways, that's just about all of my rambling for today. I'll just say hi to the chat people and then we can get started here. So we got Victor joining, and Victor has given me 2 likes already. Victor, I say to you, cześć and dziękuję, which is hello and thank you. And so Marco asks, have I checked Flux architecture? I can answer that right away. I haven't, Marco. And we'll just see, got a couple people, some people. All right, we got a good amount of people in the chat today. Okay, so I've been rambling for quite a bit, so we're going to run through this lesson pretty quickly. And, well, famous last words, and then I will stick around for some Q&A after that. But without further ado, as a French, j'essaie without faire adieu. I would like to show you some architecture. That is my French accent. So today we are going to be learning about the seal class, and that's like my impression of Romain Guy from the Google, the Android team. Anyways, so yeah, I'll shut up on the rambling and let's get focused here. So today's main topic is going to be talking about using sealed classes to help implement what I will call an event-based architecture. Now, right off the bat, what constitutes an event-based architecture is not something that every developer agrees upon. So just heads up before I get into it. But at this point, I'm well aware of the fact that many developers don't agree on a lot of the big, annoying names that they use. So I've kind of just given up on caring at this point, and I'll just try and explain my opinion on the topic and some useful things, which even if some other people have a different definition, what I'm going to explain to you should still be a really practical tip, which you can apply in multiple different levels and perspectives of software development. So what I wanted to open with is just a quick explanation of one of the, in my opinion, most important things for you to grasp whenever you want to consider doing something where you have event producers and consumers. So let's start there. So up on the board here, I have a P with a square with a P inside of it, and then a square with a C inside of it. And then I've drawn some arrows, and we got like a little ball here. So what exactly is this? So in any system, any software system you've built, you can basically look at it and classify different parts of your system as either being event producers or event consumers. So that's what the P and the C stands for: event producer, event consumer. So this relationship is just an endemic part of building software systems. Most of the time, you don't want something to be a consumer and a producer, just because things that consume events tend to require logic, and things which, sorry, I think I used the wrong word there. Things which consume events tend to use a lot of logic. Things which produce events tend to like talk to low-level parts of a system, or they tend to talk to I/O devices. And as a general rule, I don't like to put a lot of logic into the parts of my application which talk to, say, the system or an I/O device. I get not everyone cares as much about separation of concerns as I do, but I do care. There are some cases, though, where you'll have something which is both a producer and a consumer. So a great example of that would be like if you've ever done RX Java, there's like RX Relay or a publish subject, and there's different things which can behave as both. The example I'm going to talk about now is very simplified, but I want you to imagine that you can apply this to coroutines, RX Java, really asynchronous observer pattern type thing going on, but we can also apply it at the really simple level of our computer systems. So in this particular example, I just want you to imagine that we have like a view, some part of the user interface, and it's talking to what I will call a logic or decision maker class. I'm not going to use other people's words anymore for that. A class that makes decisions. I will use the words so you know what I'm talking about. Controller, presenter. I'm not going to say view model anymore. No. So anyways, but some people use a view model as a logic class, so whatever. Let's say we have 3 different events that can be propagated from our view event producer to our logic class consumer. So the simplest approach to doing that, assuming we don't have to worry about concurrency and all that stuff, is to just directly call, let's say we have 3 events we have to represent. We just have methods or functions that are called from the event producer to the consumer. So 1, 2, 3, and if necessary, the circle represents just some data payload object, which isn't always necessary. So the problem with this approach, and it's not a huge problem, but I think you'll see where I'm going with this, is that when we get into this situation, we know these 2 objects need to communicate with each other, but we don't, in my experience and opinion, we don't really want event producers knowing a huge amount about event consumers. So again, taking the example, we've got like a view class and we're talking to a logic, a decision maker. We can have the view class have like a big interface with the logic class, so a lot of different functions. But there's also another approach we can take, and this applies to event streams in general. So as opposed to having a situation where we're calling all these separate functions, we can actually do something a little bit different. I'm just trying to do this without ruining my diagram. Okay, so basically what this looks like is we have a setup where we have one single callback, one single function, or it could be one single event stream. So if you're using RxJava, I want this to click in your brain right now, or if you're using coroutines. So instead of having 3 separate interface functions, communication channels, we have one communication channel between the parts of our system. In that communication channel, we pass either a variable, which isn't how we're going to do it today, or we pass an object with a type. So in Kotlin, we have these things called sealed classes, and this allows us to achieve this very easily and beautifully. So basically what I'm showing you here is we have one event stream, which is capable of representing 3 different potential states or events or whatever word you want to kind of use. But the key point here is one communication channel capable of representing a great deal of different states, as many states or whatever events we could also say. And what this does for us is it allows us to really simplify the communication between our different the different components of our system. And when we need to add more information, as opposed to having to keep adding more direct lines, we actually just add another object in our event. I'll get to that part in a moment. We add another subclass of our event hierarchy. I know that's Klingon. Let me show you and it'll make sense. So we kind of have a situation where it becomes more like this. So the benefit of doing something like this is, so let's say we're representing this as on login click, on sign out click, on back click, on, I don't know, whatever, I don't really care. So we're basically representing as many events as we need to represent in this single data stream. And all we need to do to account for new functionality in events is we just need to change our consumer a little bit naturally. We need a decision maker to handle events. But we don't need to add anything to our event producer necessarily, except we do have to add like maybe one event. We do have to add the specific event to be sent, but we don't have to like fill it up with a ton of functions and references to the consumer. Just one. Okay, hopefully that's fairly clear. So let's get to the coding example. Okay. So what I'll show you really quickly, famous last words, as always. So let's hop into, we'll go to NoteList View. So actually, let's go into the contract. So what I just explained was a scenario where we have event producers. So in this case, that could be a view and a view model. I don't use view models like most other people, and Google seems to advocate using them. And then we have our consumer here, which has that one single channel, as you can see. So that represents that single line I was talking about. And then the different objects that I will be passing through that channel using a Kotlin sealed class is we create a sealed class hierarchy where we've got our main type. So we're always passing one single super type here to make sure that we can actually apply polymorphic behavior. And then for every event that I want to represent, I just have a different event object here, a different part of the class hierarchy. Now, if you need to pass data, you can do that too. Which one do I do that in? I thought it was NoteList. Oh, did I? I opened the wrong one, didn't I? Yeah, I totally did. Sorry, this is the one I wanted to show you originally. So when you need to pass data, so for example, this will actually be called by an adapter, and it will send me an adapter position. So when I actually need to get some value out of it, then I actually can use a data class as opposed to an object, for example. So I'm not going to spend a lengthy amount of time explaining sealed classes. I'm just going to show you how this basically works. So in the NoteList view, we've got different events that can occur. So most importantly, I want my view to let my logic class know when different lifecycle events have occurred. And then I represent those events again with my Kotlin sealed class. Also, whenever something is clicked, I represent that. Basically, any event that the view, in this case, is capable of producing, I want it to use this event object. Now, here's a neat, really quick aside. Currently, my view talks to the logic class through an interface here. Using Kotlin coroutines, I could actually just give this view a channel, or treat the logic class as an actor, which is a type of coroutine, and that would absolutely get rid of all explicit dependencies. Like, this is an interface, so it's not even it's depending on an abstraction here. But if I even wanted to take it a step further, I could actually just basically give this thing, I believe it would be a send channel. I forget the exact API, but I could give this thing a channel, which is like something, it's similar in concept to RxJava. It's like an event stream tube that you can send messages down, in this case events. So just a quick little aside there. So when let me take you into the NoteList Logic class next. So this is the decision maker. This is the callback here. So this is our big event stream capable of representing all of the events that I necessarily need to represent. Whenever I want to expand the functionality of this thing, I just add more events like that. Pretty easy. And the thing which is really, really cool about doing this is look what it does to my test setup. So I'm going to open up NoteList Logic test. And so basically how this works is when I want to pretty much test almost all of the logic of a given feature, because I've taken the time to separate concerns and I'm not filling a view model with business logic and shared mutable state, what I can do is very easily cover all of the events which are expected to be produced by different components, by the user, by whatever. I can cover all of them in my unit tests. And all I have to do is I just call whatever event I need to in the logic class that I'm testing, just like so. And then I test what happens after that. And then after that, all I need to do is, since events can, so when we're testing events, we're testing behavior, but we're also testing state. So a given event, so we say on new note click, we're looking at this one here. So what we can do is, I haven't prepared this ahead of time, but what does this one do? So on new note click A. So A, the user is in private storage mode, and then we have B, the user is logged in when they create a new note. So basically what that's going to allow me to do is I cover not only the behavior that should occur based on an event, but if an event can have different values and that changes the behavior, then I cover that as well with a series of unit tests. And so this has been working incredibly well. As you can see, I've got a lot of different tests, and I basically, in order to just be sure that I'm adequately handling test coverage insofar as I would like to, I basically just try and unit test all of these different events, and once that's ready, I'm pretty much done and I can move on to the next feature. So there's one more usage of sealed classes, which is very handy. So in my domain layer, you'll find I have, do I keep them in here? Maybe I don't. Yes. You'll find that I have another sealed class. Let me just get some space here. I've got another sealed class, and so it's a similar thing, and again we're representing one single payload, one single stream capable of representing different states. So for the result wrapper in particular, so we've got value, loading, and error, and I can represent those in my unit tests as well very easily. So where's an example? Yeah, so you can see I frequently build these result objects, so they get built there. And there's another sealed class for errors. But yeah, so we've got our result wrapper, and this thing is very, very handy because what it allows us to do, go back to the whiteboard for a moment here. So whenever we make like a call to a sub-component of the application, a service of the application, almost invariably you have to at least cover success cases and error cases. So we'll represent an error case with the orange marker down here. And then you have to test, of course, success cases. And there's a lot of different potential events you might need to handle, but in this particular case, I also represent a loading event, which would actually fire before we determine whether it's successful or not. So that's basically, in my opinion, one of the most useful ways to leverage sealed classes in Kotlin. They work incredibly well for representing a single event stream which can have multiple different states represented. And the best thing about that is if you're into testing by covering all of the different sealed class states, you can essentially figure out if your program is complete and improve testability with it. So that is my discussion on sealed classes, event architecture, and how that can help you testing. So hopefully that was useful. If it was, please do me a favor and hit the like button down below. And yeah, let's get to some Q&A. Just going to run a quick commercial break. And if you have an ad blocker on, you can wait with everyone else. Okay, so let's get started here. Okay, let me start with this. So oh, my setup is awkward today. I had to move my computer way away from my microphone to try and reduce the obnoxious CPU fan noise, and as a result of that, it's screwing up my setup here. Anyways, so let's try and spell your name correctly. Okay. What I'll do, I'll just kind of read out a couple comments here because there's a couple parts to this question. And so Victor asks, so imagine that you have an application. This app is giving a lot of information for a user. And what about offline content? Is it a good idea to make room and save everything from JSON there? Or is it better to save JSON and parse from it, but in this case, user will only have things which he clicked before going offline. And creating room, it might be a pain in the ass because the application is huge and there are many instances for this application. Is room the best idea? So I'm gonna give you my general thoughts on this because it's a huge, it's a big topic. So the thing I'm going to really focus in on here is, okay, so we have online, offline content and how to kind of manage that. So I've been saying this for weeks now, and I am actively building Space Notes, but I still don't have the code to show you the actual implementation. I am very close to getting there, but life, you know. I'm not good at estimating how long it takes me to do certain things, to be honest. So I'm trying to think of how to demonstrate this. Okay, so let's say we have, so Space Notes is essentially going to be a note-taking application, and it'll have a private data source which contains both a local, so it has a private data source, and in the private data source it will have both a local and a remote repository. And then when it's in public mode, the user will only be writing to a remote repository. So I'll explain why that occurs once the application is further along. But let's focus in on the private note source. So what we need to be concerned about is I want Space Notes to function online or offline. I want it to be able to automatically acquire network connections properly and things of that nature. So that's the part I was busy with over the past couple of days, and I've had to do some learning about actors and channels in order to figure that out, but now I'm rambling. Let's just open up private node source. So in the private node source, I'm going to be talking to both a local and a remote database. I will have the actual implementation to show you soon. So essentially this is the key problem. We're trying to set up a scenario where we have both a local data source and a remote data source. So if you use Firebase, Firebase is actually capable of handling online, offline data persistence itself to a degree. That's one of the nice features about it. I am using Firebase, but I'm actually still going to be using a Room database for local. So I'll open up, so that'll be Room, Note Repository Impl, and then there will be Firebase Note Repository Impl. And I might actually switch to Firestore instead of real-time database. We'll see. But the basic gist of it here is, so whenever, to answer things in kind of a generality, whenever the user does something like requests a note, get notes, or updates a note, or something like that, I don't plan to rely entirely on the Firebase API to handle all of that for me. So I am going to have a Room database to manage offline user persistence. So the thing where that gets tricky is you then need to coordinate, okay, if I'm offline and I wrote to the local database, when I reacquire the network connection, do I update the remote database automatically? How to configure that kind of thing. So it's a tricky problem, which is why I'm kind of learning and implementing coroutines at the same time as implementing this problem or solution. But the basic gist of it is, so Room is pretty easy to configure. I would probably recommend it for offline user persistence, as opposed to, say, you mentioned JSON. You can serialize JSON, so if you don't have a huge amount of data for a given user, maybe it doesn't make so much sense to use Room. In this case, this is a note-taking app, so I do definitely want a fairly expansive offline data store. But beyond that, we're getting into like implementation details of the thing you're trying to build. So I think I'll have to leave that question there. But hopefully some of that rambling was useful. I do think Room is pretty awesome. I've also used Realm in the past, and that's a pretty good option as well. And Realm is kind of nice because it does have multi-platform support, but on Android I usually just do default to Room at this point. All right, what else have we got? Okay, so Suleiman says, I hate Kotlin. Thank you for sharing that. D Phoenix asks, hi Ryan, big fan. Could you do a DI course/video specifically for Kotlin? Maybe using, you picked things I won't use. I won't use Kody, nope. And I don't like model view view model the way almost everyone does it, because they don't actually do model view view model. But I do want to do a dependency injection tutorial soon. So the thing I'm struggling with is I'm trying to see if I can build my own dependency injection implementation quicker and easier myself than using Dagger 2. So I need to figure that out, whether that's a feasible solution. ahead of using Dagger 2, because it's really annoying to teach Dagger 2. It took me many months to understand how to use it. It really is one of the most complicated tools I've ever used. So it's tough to even advocate people using it. Like, you have to be a real hardcore programmer to implement it properly. So you can implement it in a really simple way and get minor benefits to it, so I might go that route. I used to basically have Dagger 2 manage my whole dependency injection setup, and there are definitely benefits to doing that, but the problem with it is predominantly that if I show you one specific way to do it, and you don't structure your applications the same way I do, which is pretty likely, then the implementation of Dagger 2 I show you might not actually help you implement it in your own application. And then again, I'm sure anyone who's worked with Dagger 2 has had this. You pull up 5 different applications that all have Dagger 2, and you're trying to figure out, like, okay, how do I make this work? And then you go to app A and they do it differently, and then you go to app B and they do it differently, and then you go to app C and they do it differently, and then you start trying to pull ideas from all of these things, and maybe after 2 weeks your project is finally building. So don't get me wrong, I like Dagger 2. I think it is the best dependency injection framework out there, which is one of the reasons why I won't use coding. But at the same time, it's just pardon my language, it's a fucking nightmare to teach people. It really is. So I'll see what I can do anyways. What else have we got? Yeah, so Marco, as a follow-up, mentions, what do I think about using coding versus Dagger? If you're going to use a framework, I would suggest Dagger. If you're not going to use Dagger, I would handwrite it, which is typically only feasible in smaller applications. Okay. So I see Victor mentions about coding. So the specific technical reasons why I prefer Dagger over pretty much all the other dependency injection frameworks is that Dagger generates your dependency injection implementation. It builds itself, all the code, at compile time. So that means when Dagger finally does build properly, you can look in your build folder in your project, the generated build folders, and see everything it's generated for you. That has many other benefits to it, like compile time, error checking. There's some more advanced reasons why I really do suggest Dagger 2 or nothing. But anyways, I won't ramble too much about that. And the chat just jumped on me. Okay, now I have to find where I was. Okay, what's up? We got Sergio, the line, Martin. So a lot of people are commenting Kody. Yeah, so for those wondering, coding, yeah, it's easier to understand and use, and there are great. Here's the last thing I will say about Dagger 2. Dagger 2 is not arbitrarily complicated. Their names are tricky, but Dagger 2 is as complicated as it needs to be to create a really powerful tool. So you are losing a fair amount of... I'm not saying never use coding. If it works well for you, that's fine, but yeah. Anyways, just understand there's plenty of technical reasons to prefer Dagger 2. I'll have to get back to you on that question in the line because I'm going to be publishing Space Notes soon, and to be honest, it's actually been a while since I've published an app to the Play Store. So I don't really have... Let me refresh that process myself before I go talking about it. I got asked what's a sealed class by Sergio. I would go back and watch the the recorded version and watch my intro, because I could verbally define it for you, but you really should just watch what I went through, and then you'll understand what a sealed class is. Because if I were to, here's the definition of a sealed class. It allows you to create a sealed type hierarchy, a hierarchy of sealed finite types. And what that allows you to do is then you can have a situation where you can use an exhaustive when matcher in a situation like this. So NoteList event is the, where's my contract so I can show it to you. NoteList event is the sealed class, and then all of these are subclasses to it. And then we have like an exhaustive and sealed type hierarchy. And in use cases like this, it's very useful. But when working with sealed classes, look at practical examples, because if you just look at it based on its definition, it's probably not going to tell you anything. They really are super useful in super specific cases. What's up? We got Coding and Flow as well joining. What's crack-a-lackin'? Definitely not this room. There is a cracker right here. Okay, I can try and riff on this. This will be... It's a good, interesting question to try and riff on. This is normally something I would want to try and prepare ahead of time, but I'll do my best to answer. So Anton asks, what is the profit of the event-based approach? Why is it better than different method invocations? So to give a practical example, if I open up, where is it? iList. So if I open up my contract class, I'm gonna go to VCS, local history, show history. And so I hope it's gonna give me a reasonable, okay, yeah. So as a direct benefit, in the application, I made this change. Actually, I think I made this change yesterday because I'm trying to move towards more event-based architecture. So the primary benefit of having one channel capable of representing multiple states as opposed to multiple channels capable of representing one state, the primary benefit is that it can allow you, when you apply it with something like the observer pattern. So to summarize the observer pattern really quickly, it really is just representing different parts of your application as either an event producer or event consumer, sometimes both. There's valid use cases for like a relay, something that consumes an event and then gives it to some other part of the application. But the main benefit is that it really decouples your architecture. So I don't need to have a huge number of different events that I have to call from my view class to my logic class. This is like the old approach. Oh, not sure what it did there. And this is sort of the more event-based approach. And then that also, not only do I have the view calling back to this event logic interface, but I also have the view model, the adapter. Let's go to the adapter. Basically, I can represent a single feature-specific... I hate it when my mouse screws up like that. That's so annoying. I need to get a new mouse. It sends random click signals, so I'll be trying to select something and it'll think I'm clicking and dragging. Anyways, so yeah, what I'm trying to do with this pattern, this event-based pattern in general, is I want one kind of class that handles all of the events for a given feature. I really like to keep app features separate, so this works with my architecture. I'm not saying you want to have one single event handler for the entire application. That would probably be insanity, and that would be close to how the first people who explained model view controller basically explained it to me, that that's what the controller would do, and that was very confusing. Anyways, the main purpose is once we establish our all of the potential event states, we get a situation where I don't need my view to basically know a huge amount about the interface of the consumer. That's kind of one of the primary benefits, is it cleans up interactions between producers and consumers. Then not only that, but if I've actually covered all of the events that can propagate from all different sources, then that allows me to jump straight into unit tests, or whatever testing you prefer. And then I'm essentially I'm testing directly on these events. So let me just review. I forgot what the question was exactly. What is the profit of the event-based approach? So I like it because it allows me to design my programs in a very calculated, finite way, assuming that I've represented all potential events and I've covered all potential events with adequate test cases. Then I am very, oops, sorry, tapped the microphone there. I'm very comfortable with my code coverage. Some people would say I should also test the view and do 100% code coverage. I don't, maybe I'll weigh in on that when I actually try it, but I'm kind of too lazy to do that. But in my style of architecture, my goal is to just compact and pull all of the logic out of everything that everyone else fills with logic into one kind of area for a given feature, test it, and I find the best way to have all of these things just delegate their events to this central logic decision maker is with an event-based approach with sealed classes. And then we no longer have to have a situation where I have just a gigantic series of callbacks to this event handler. Even before, I experimented with having just like function clear and bind, and then I was like, why don't I just represent those with events? I can't, my face is in the way, sorry. How can I get this to show up properly? So, oh, this is so janky, this stupid UI. But yeah, I just basically represent all potential events. Anyways, I think you're pretty clear on that. So off the top of my head, I'm sure if I thought about this for a while, I could probably give you some more information. But the basic gist of it is once you start to represent your application in like an observer pattern type scenario, event producers, event consumers, subjects, and subscribers. There's all kinds of different ways of naming it. Observable, observer. Once you start to get into that situation, that's where event-based programming with restricted hierarchies of events really starts to shine. So it cleans up the interfaces between your event producers and consumers and opens the door to a very decoupled architecture, in my opinion. So that would be my answer there. Hopefully that was reasonable. Sergio asks, is Room cool with live data integration? I don't like to use live data outside of my front end, but it is very well integrated. So if I go to my Room implementation, I'll show you the DAO. I don't actually return live data objects. Now this is possible because when I call these, when I call these functions on the DAO, if I go to the class that does that, let me just clean some stuff up here. So that would be Room Note repository. So because these are suspend functions, I can just ask the Room database, the DAO, for the data that I want, and I don't have to worry about pulling a live data or anything like that. And the reason why I go through the trouble of doing that, and then, for example, mapping to and from a Room-based data model to, let's hop into our domain model, which has no annotations, or we can look at our Firebase note repository, which has its own specific kind of data model that gets mapped again when I want it to our domain model. If you are concerned about multi-platform support and good separation of concerns and being able to say, for example, switch very easily from Room to Realm, from Firebase real-time database to Firestore, if you go through the trouble of separating your concerns like this, then your architecture is really easy to work with. Now, as always, there are people who will say, that seems like a lot of extra work if I'm not actually certain that I'm going to change to a different thing. As far as that's concerned, if you are absolutely 100% that you're only ever going to use Room, yeah, you pretty much don't need to bother doing what I'm doing. In this case, I have multiple different data sources which are all returning the same domain model, in a sense, the same kind of information, a note or a user. And so in that case, that's why I go through all this trouble. I don't know how I got to that. I was talking about live data and then I just went off on a huge tangent there. But yeah, Room works with live data really well. You can have it just return live data objects, and I do have a video where I talk about live data and explain kind of how it works. So Sergio mentions Coin. My opinion on Coin is pretty much exactly the same as it was on Kody, although last time I looked at Coin, that was a year ago, so maybe it has improved. If they still use reflection, then yeah, I'm not sure. Again, so Victor asks about ProGuard. I will be figuring out how to properly manage. Yeah, I don't have a good answer for you at the moment about that. It's been a while since I actually fiddled with exporting projects for publishing and stuff like that, so it's just not fresh in my brain. Okay, I could try and talk about that. That's an interesting topic. So Martin... Okay, so what I'll do, we're already at the hour mark, so Isaiah, I will answer your question, but I'm just going to riff on an opinion-based question before I get that. Okay, because I do need to clarify something, so Martin D... or I'll just say Martin. This is a very important thing to clarify here. So the question is, Ryan, why don't you like architecture components? So number one, I love architecture components. although I understand why you might think I don't like it. Talking about view model, room, and live data, what is your point of view about it, and why am I not so happy, or and why do I not agree with them? So let me clarify a couple of points. So I love architecture components. I use view model and live data. So here's what I don't like about some other things that Google has done recently. And I'm not saying I know better than Google's developers, but all I can really do here is comment on my own experience as a developer. The word view model has become so denuded of an actual solid definition, and the fact that Google chose to call their view model API as such has caused a very immense degree of confusion for myself and a great number of developers out there. So when I criticize the word view model, that's not actually me criticizing. If I go into, let me show you a view model. This is a very important point for me to clarify, because you might have assumed that I was crapping on the view model from architecture components, but that was not what I wanted to open. There we go. But what I'm actually crapping on is the way people use it and the way the Android team is kind of directing people to use it. So let me explain what that means. So as you can see in my front end features, you'll, unless I really don't need one, almost always see a view model, which does extend a view model in architecture components. And I do also use live data in it, because live data and view model play together very nicely. So I have nothing against either of these tools, other than to say that I don't want them anywhere near my back end of my application, because I plan on doing multi-platform applications. So that's why I don't really want live data being passed through my domain layer, if you're kind of wondering. Now, why do I complain about view model all the time? So let's talk about names. Names are very important. I have been tortured since day one, and all of you listening to this have as well, by the fact that us developers can't actually agree on what things mean. So model view controller originally meant something by this, I believe, a Norwegian guy named Trygve Rinskau, who explained it as like a fundamental way to handle GUI architecture widgets. And then that got morphed into what I read about on Model View Controller in 2013, which was very far removed from what it meant before. The architecture model view model is not new at all. It's had other names over the years. Presentation model was one of them. It's had, I think another one was like application model even. So what we have is we have a situation where people use different words for everything. I'm guilty of it too, because I can only work off of the information that I'm given off of the internet. And why I am particularly pissed off about the name view model, not view model from architecture components, although I do wish they had called it something else, to be honest. Well, I don't if... this is so hard to unpack. The way I use view model is exactly like the name sounds. It models the data necessary to render the view. So that's how I use view model. If that's the concept, the programming construct that you are pointing to with the word view model, I have no issues with that. What do I have issues with? This morning I watched a presentation from Google I/O, And the sentence came out that view models are a great place to store your business logic. Now, I am not as good of a programmer as the individual who said that, but that really bugs the hell out of me. Because, okay, so we've got a logical decision maker class, and to a beginner looking at it, they immediately assume that it's a data container for the view. In reality, how Google seems to advocate using it is both a data store, like I use it here. So it's both this thing that I show you here, just a simple front-end data store that keeps data safe from the fragile life cycle. And then it's also the logic class. So let's open that up. It's also the logic class that dictates the business logic of the application, the logic in general. So the reason why I always complain about this is that model view view model is not a complete architecture if you define it as the name suggests. You have to have a front-end decision maker class if you actually want to perform separation of concerns. So that's basically the gist of it. So when I complain about model view view model, I'm complaining about that particular pattern, which is not well defined. Google knew, some engineers in a podcast from Google fully admitted that when they were selecting a particular architecture for architecture components, when they were going to put their weight behind an architecture, they fully admitted that view model is not a consistent pattern. I've gone into what actually constitutes the view model pattern, the model view view model pattern, and it's not what most people think. But the basic gist of it is I don't like that Google has basically diluted this name view model such that it's not even it's now some. Here's the gist of it. Let me summarize it like this. Okay, so what is the key to separation of concerns in a computer system? There's 3 kinds of code that you will ever write. I won't bother using different colors. Sorry. Okay, view, logic, model. So, there's 3 kinds of code you will ever write as a graphical user interface application developer. Either you're going to write code to draw something on the screen, you're going to write logic to dictate just events and the flow of the application, and then you're going to have what I call data. Other people call it model. So model models the data. That's why I just say data. It's easier. And so we have something called view model. So we have a name that points to this layer, and it also points, to this layer. And what do we have inside of it? Logic. So by having a thing called view model and filling it with logic, that is literally like the ultimate antithesis of separation of concerns. So that's why I don't like I always complain about view model. That is basically the exact reason why. So anyways, hopefully that explains it. I do really like architecture components. I'm not saying I'm a better developer than people who have implemented view model really well. You can do view model properly. All I'm going to say to you is I really do think separation of concerns is important. It's been one of the most important things in my architectures, and I hate that we basically have the name of a concept which points to two separate layers, view and model, and then people fill it with logic, because that doesn't make any fucking sense. So anyways, that's basically it. Never used logic inside of Google's way of view model? So Sergio, could you rephrase that a little bit? Sergio says, never used logic in, there's one word, I'm not sure what that means, inside? Never used, because it, depending on how I'm reading your question, I think you are using it properly. Let me really quickly show you. Here's how you, this is why I don't actually, yeah, so Sergio says, I've never used logic inside the view model. So I agree with the way you are using it, Sergio. I think you are using it properly. I think everyone else is using it wrong, essentially, not everyone. I don't think there should be any logic in something called view model. So if you want to use kind of MVVM and you have a complicated front end, what I would suggest is just forget about calling it model view view model, forget about calling it model view presenter, do what I do in Space Notes, which is to have, so we've got our M, V, VM, L. So we have model, or our data store, we have front end data store. So this is what we need to render in the front end, and if the user rotates the phone, we restore that state from here, or sometimes we re-query the model. It depends on what you're doing. You have the view to render the view, and then you need a logic class here. So if you want to do model view, view model controller or presenter, if you want to do model view presenter plus a view model, I don't care what you call it, but my general tip to people is don't be fooled into thinking that you very, very strictly have to just have a model, a view, and a view model, because if you do that, when your application gets complicated, you actually have to fill this thing with logic, or you have to fill that thing with logic, or you have to fill that thing with logic if you don't have a logic class. So that's just my general tip there. Okay, let's get to Isaiah's question. In closing, my greatest criticism of view model really just comes down to the name. It's a stupid name for the way people implement it most of the time. Anyways, let's go to Isaiah's question. So, can I explain in and out generic types? Okay. I'll try and explain this relatively quickly. So, in and out generic types. Okay, where is my sealed class? Okay, let's see if I have the brain power to explain this in a reasonable way. Okay. So basically, when we're dealing with generics, in certain situations we need to retrieve specific types in our subclasses that, okay, how can I, just trying to think of a serviceable way to explain this. I've never actually verbally explained this, so that this could be tricky here. I understand them based on what they do. So the basic gist of it is, so I'm just struggling to remember the use case for in. So out is obviously when we want to get some value, some type, and we need it to show up. Let me hop into the generated bytecode and see if I can figure that out. I'd have to just get back to you on this one. Okay, so result.decompiled. I'm just trying to see exactly in the code how it changes the result object. So we've got final class value. Where is result? So here's just a pro tip if my answer completely fails, which it might. A handy thing about Kotlin is you can look at the generated bytecode and kind of get an idea of how things work under the hood. Class. So, and from there you can often answer these sorts of questions. So I'm trying to give you an answer which actually points to something useful. So object, so we have a generic object, get value. Yeah, I don't think I'm going to be able to explain it in a way beyond saying when you want to get some type. That's not going to... Look, I could sit here and say like out is how you get a value out of the data class and the object class, and in is how you get a value in, but I'm not going to... if I were to give you a vague answer on that, I would be lying to myself that I don't understand the concept itself 100%. So what I'm saying here is in terms of a mechanism, it allows you to say I want this particular type to show up in, say, the subclass. I don't know. Let me get back to you on that one. I can't parse. In simple terms, I know how to use out, but I have never had an actual use case for in. And if I don't have use cases for something, I don't typically understand them very well. So yeah, I don't have a good answer for you, but this will give you a hint as to how out can be used when you don't want a given generic to pop up in the subclass in this particular case. Let's pull up the Kotlin documentation and see if that can clarify it. I'll see if I can parse it from the docs. Okay. Okay. Oh, right. Yeah. See, this is why I can't explain in and out for you in a way which I normally would explain. Is I remember when I went back to learn in and out, I just ran into a lot of jargon which I don't immediately understand. And so I don't have practical experience or use cases to actually explain how this works outside of the jargon itself. Consumer in, producer out. So when you have something that produces a value, that's just a generic, yeah. Anyways, I'm going to shut up. Let me get back to you on that. What I'll do is at the start of the next episode or in a Kotlin WTF, I will sort my own shit out and explain what it means. yeah, I just don't have, I need to find the use cases. Once I find the use cases, then I can decipher the jargon for you, and that'll be that. Anyways, that's basically it. Thank you for watching, and it's been a pleasure. So tomorrow I will be doing the live coding again, and we'll probably be working on space notes as well. And yeah, hopefully that was a decent episode. I kind of went all over the place there with a lot of topics, but great questions today, and thanks so much for watching. We'll see you tomorrow. Or, yeah, some of you tomorrow.